Thanks for joining us and welcome to the MLOps Live webinar series, where we talk about bringing data science to production and creating real business value with AI. My name is Sahar, I'm the VP of Marketing at Iguazio, and it's great to see all of you with us again for our 20th episode. Today, we're going to be talking about how to easily deploy your Hugging Face model to production at scale. And I'd like to start by introducing our speakers who really need no introduction, these three. Our first speaker is Julien Simon, who is the Chief Evangelist at Hugging Face. Prior to joining Hugging Face, Julien spent 6 years at AWS as the Global Technical Evangelist for AI ML. And before that, he spent 10 years as the CTO and VP of Engineering in a series of large-scale startups. Secondly, we have Noah Gift, who is one of the top voices in MLOps today. He is an accomplished author, and he published the book Practical MLOps by O'Reilly. He's working on a second book now called Implementing MLOps in the Enterprise, together with Aaron Haviv. And he has a couple of other books in various stages in the pipe. He is also a lecturer at Duke and has a couple of courses on Coursera, very big advocate for MLOps education. And he's the founder at Pragmatic AI Labs. We're very excited to have both of you with us. Last but not least, we have Aaron Haviv, who's the co-founder and CTO of Iguazio. Aaron has spent decades in the data and AI space and initiated 2 open source frameworks called Nucleo, the serverless framework, and MLRun, the MLOps orchestration framework. He is also sits on the data science committee of EA, and it's a pleasure to have all 3 of you here with us today. And this dynamic trio is going to take us through a couple of very exciting topics. We're going to start by talking about the key challenges to operationalize machine learning. We'll give a quick introduction to Hugging Face and MLRun, and we'll really focus on deploying your Hugging Face model to production at scale in a reproducible way, because we all know how challenging that can be. And we'll finish off with a live demo of Hugging Face and MLRun, taking you through the entire MLOps pipeline. And we'll leave plenty of time for Q&A at the end, so you can ask your questions live. At this point, I also want to invite you to join our thriving community of over 800 data scientists, ML engineers, data engineers. That way you can continue the conversation with our speakers and, of course, with each other. We'll just drop the link in the chat now. And we'll be running 2 polls about your MLOps journey. We really want to hear from you. It also helps us make these sessions as valuable as possible for you. So please do fill those in, and we'll make sure to share the results with everyone at the end. In terms of Q&A, feel free to add your questions as the session goes. We'll answer some of them as we're going through the different topics, and we'll save most of them for the end so that we can have a great kind of live discussion. And that's it. We'll now put everyone on mute, and we're recording the session so that we can send it to you afterwards and you can watch at your convenience. And with that, I will pass it on to Noah to kick things off.
All right. Yeah, I'm ready to talk a little bit about some of the stuff I've been doing recently, especially with Duke students. One of the things that is a challenge now in the environment that we're in is that we're in a recession. It looks like maybe there's going to be a recession for the next couple of years. And as a result, I've mentioned to students that Hugging Face in particular is something that they should invest in, and they should learn about how to really efficiently build models and put them into production. And I think I can't think of a better technology that actually is going to showcase their ability to do it. And this is something I was talking about just yesterday, actually, is that the models really have this life cycle where you not only use the models in web apps, Hugging Face Spaces apps, GitHub code spaces, command line tools, but you also can pick a particular revision, download it, you can upload it, put it somewhere else. And then really the special sauce of a lot of the stuff that's happening is you can fine tune a model. And this is where we really do need lots of assistance and lots of tooling, like, for example, MLRun, because in some cases, you may want to have a large scale fine tuning process that uses maybe a cluster of GPUs or add some special data. And also you would like to keep track of your experiments. But in a nutshell, I would say, I can't think of a technology I would recommend more than for people to master the Hugging Face model lifecycle. I'm ready for the next slide. And really what this culminates to is to think about a pretty revolutionary change in machine learning. I think it's not going to be difficult to find many examples of slides that say what is AI, what is machine learning, right in there, and they always talk about unsupervised machine learning and supervised machine learning, right? Those are the two things that are kind of traditional things to talk about. And of course, we need supervised machine learning. It's historical data that you train to make a prediction, like can the points that you score in a basketball game, can they predict your salary, like as a professional basketball player? But one of the problems with supervised machine learning is that we have a constriction on data and we have a constriction on compute. And especially, again, going into a recession here, there's global warming, there's all of these issues with being, I guess, wasteful with your resources. And we don't need to do this. We don't need to reinvent the wheel. And this is where transfer learning comes into play, is that we can stand on the shoulders of giants and we can actually take these huge LLMs or large language models and actually just tweak them a little bit and use the best of that particular model. Like in the case of a news data set, you could go through, grab just the body of the news data set and then swap off the head and then make it do a summarization for 18th century literature, right? And this is one of the great advantages, is to leverage the powerful resources that are being developed from OpenAI, Stable Diffusion, Google. These kinds of companies are building these models, and then with Hugging Face and some of the ecosystem here, you can just tweak a few little knobs and then use a high quality model that was trained in a planet friendly way. So that's really the advantage, I think, of transfer learning, especially in the coming years, 2023, 2024. There's going to be a reckoning, I think, in terms of people asking for your spend and saying, why are you spending all this money on an inefficient training process? We need to focus on efficient training processes. So that's my section. Oh yeah, we have one more slide here, which is that another component that is really important to consider as well is that once you have enough of a AI ecosystem available, which we do in the year 2022, you actually have AI tools that talk to AI tools that create AI. So you have this essentially a feedback loop that allows you to be extremely productive. Here's just one example, which is that I could launch up, let's say, GitHub Codespaces. I could use a Copilot tool that helps me write code. In fact, it could help me write Hugging Face code, Hugging Face, suggestions. Once I take that suggestion, I could then create a model, take that model, and then put it back to the cloud-based environment, and then deploy it. So really, this is like a meta AI enabled programming system. I know I was talking to Julien earlier, and he's doing similar things, right? We have Hugging Face technology that talks to some other pre-trained model that then creates synthetic data sets. So I think this is another really important concept that is going to explode, I think, in 2023 and beyond, is that you actually need AI tools to help you create other AI tools.
Thanks so much, Noah. And what a great segue, Julien, to your presentation.
So good morning, everybody, or good afternoon, depending on where you are. Thanks for joining, and thank you for having me today. So I'd like to tell you a little bit about Hugging Face and why I think you should care. A trend that we see today is a reinvention of deep learning, and one way to put it is that transformer models are eating deep learning. Of course, we've been doing deep learning in the last few years, and we've used, I would say, traditional architectures like CNNs, LSTMs, RNNs to solve a number of problems with unstructured data, like, of course, natural language and speech and images. And those models have proven quite efficient at it. But for a few years now, and specifically since the release of transformer models and Google BERT in 2018, we've seen this transformer architecture being very efficient and in fact, more efficient than anything else on extracting insights from unstructured data. So whether we're talking about natural language, we have models like BERT and BART and GPT-2 and GPT-3 and our very own Big Science, which is an open alternative to GPT-3. Whether it's computer vision with a CLIP and the vision transformer, and of course, stable diffusion, the text to images models, or whether it's speech to text with Wave2Vec2 from Meta, or the latest Whisper model from OpenAI. Basically, we see state-of-the-art benchmarks being improved on by transformer models. And it's not just us and researchers saying it, it's really picked up by the industry. So in last year's State of AI report, transformers were called out as a general purpose architecture for machine learning. And in the Kaggle data science survey, we actually saw RNN and CNN usage going down in actual usage and popularity, and transformers going up. So we really see this, like I said, this reinvention of deep learning based on the generalization of the transformer architecture. Next slide, please. And the latest State of AI report came out a couple of weeks ago, and one slide really caught my eye. And that's the slide, obviously, you see here. And this slide shows the modality of transformer usage in research papers. So a couple of years ago, transformers were massively used for NLP, 81%, almost zero image stuff, almost zero speech projects. And in just under 2 years, we see that now NLP is actually the minority use case, only 41%. Image is exploding, 10x or even 11x in just under 2 years. And we see different modalities, rising as well. Audio, video, multimodal is very strong. Like I said, text to image is rising fast. And other use cases like recommendation, protein, and drug prediction, et cetera, et cetera. So this is another very strong sign, not to say proof, that the transformer architecture is generalizing to a lot of different deep learning and even machine learning use cases. Next slide, please. And so coming to Hugging Face, so Hugging Face is a company, and it's also the steward for open source projects. And the most popular one is the Transformers library, which lets you download models from the Hugging Face Hub, our main website, and fine-tune them, predict with them, etc. And this Transformers library is actually one of the fastest growing open source projects ever. And you see the GitHub stars for various projects on the slide here. Hugging Face is actually the blue line on the left with the little starship. And you can see it has the steepest slope, and the trend just goes on. We're way past 70K stars. So trying to get to 100K if you haven't started the library yet, we'd appreciate your help. And we can see we're growing faster in popularity than amazing projects like PyTorch and Keras and others. And we're even growing faster than Kubernetes, which I find completely mind-blowing. So this continued adoption in the community is, again, a strong sign, and it's just not, it's just not a fun toy to play with. ML researchers and developers are getting work done with transformers. Next slide, please. And I just mentioned the Hugging Face Hub, which is, again, our main website at huggingface.co. And people call it the GitHub of machine learning, and I guess that's a decent analogy, because just like you go on GitHub to find code for your projects and share your own code with the community, well, you go to the Hugging Face Hub to find models and data sets for your machine learning projects and to share them with the community. So if you could just click on the slide, please. As of today, we have a reasonably large number of models. When I put this slide together literally a week ago, it was 78,000 models. I checked just before the webinar, and now it's 81,000 models and I think over 12,000 data sets. So it's growing very fast. We have over 10,000 organizations, from Google to Meta to NVIDIA to Microsoft, to research labs, companies and individual developers sharing models and data sets every minute. And we have way more than 1 million model downloads every single day. So this shows, again, the popularity, the continued popularity and usage for Hugging Face models. So I encourage you, if you've never checked it out, you can go to it right now. You can, or I guess after the webinar, and you can sign up in seconds. It's completely free. It's open source, and you can start experimenting with models. Next slide, please. And just before before we continue with the deployment discussion, I wanted to show you really quick, if you've never seen Hugging Face, what it really means. We try to build simple tools that let you use state-of-the-art models in the easiest possible way, even if you're not a machine learning expert. So if we have experts today in the webinar, of course, we'll need the experts always to keep advancing the state-of-the-art. But if you're a developer, if you don't have a formal training in machine learning, you already understood what this code does, and that's exactly what we work on. Make it simple. So here I'm just importing the pipeline object from the Transformers library, and starting from a pre-trained model from Facebook, which is the BART model, I create a pipeline for zero-shot classification. So zero-shot classification is an NLP task where we start from a piece of text. And this is actually a sentence from Wikipedia. And we want to score the content of that text against an arbitrary list of labels. So unlike traditional classification, where labels are, I would say, defined in the training data set, here I can pass any list of labels, any arbitrary labels, and get a score. And once I have that pipeline, I just invoke it on my sentence, passing my labels, and I get my score. And that's it. That's all there is to it. And this is how you do your zero-shot classification in literally 4 lines of Python code. And what happens under the hood is crazy complicated, of course, but we don't need to know. All we need to know is, what kind of business problem are we trying to solve? What are the popular models to do that? And you can see them on the Hugging Face Hub. You see the popularity metrics like the number of downloads, and you can start from there. And anyone who can write Python code, simple Python code, can get the work done. So here, obviously, I'm running I would say a simple prediction, but what happens when we want to deploy this in production, for a 24/7 usage? That's where the real problem starts, right? Because of course, first of all, you want automation, right? So you want a simple, reliable way to go and deploy those models into prod, and then you want to have a scalable and a solid way to manage that stuff in production. So working in Notebook is one thing, but automating and scaling your MLOps workflow is another thing. And I think that's where we want to hear about ML Run and how we can do this with Hugging Face models, how we can bring those models in production in a solid and simple way. So back to you.
Thanks so much, Julien. Those are some impressive stats, I have to say. And at this point, I want to invite, actually, we're going to pause quickly for our first poll. So we want to hear from you. What is your biggest challenge when deploying your Hugging Face model? Of course, we'll share the results at the end, like I said. All right, I'd now like to invite Yaron to talk a little bit about the next stage, which is deployment and management in production. Yaron, over to you.
Yeah, so thank you, Sahar. Before we dive into a demo that we prepared here, so let's go over some of the details. So we're going to show how to deploy Hugging Face models to production, to real-world endpoints, along with data preparation, sort of a real application pipeline with data preparation and post-processing and so on into essentially serverless functions. And also another thing that we're going to show how we can retrain the model with fresh data set and in order to update the model to something more accurate. MLRun is an open source project. We're going to go into it in a second in the demo that has all the things that you need to automate your MLOps workflows. We'll show that in a second. The four main components in MLRun are a feature store for the feature engineering aspects, the sort of fully automated flow for building the models, including testing, training, deployment of models to production, and so on across a distributed cluster environment. You have a notion of real-time serving pipelines, so it's not just serving the model, but it could be any other application aspect like data preparation, API integration, activities, and so on. And we're going to see how it plays into NLP pipelines, which usually have more than just scoring a model. Usually there is some data processing and other aspects. And the other thing that MLRun has is the real-time monitoring of all those endpoints and essentially triggering some actions like retraining or alerts and so on. And next. MLRun essentially comprises of a client and a server. The server is running on Kubernetes and can run on any cloud environment, also on-premises, on virtual machines and Kubernetes. And there is a client side. The client could be anything you want. Could be Jupyter notebooks, VS Code, SageMaker, Azure ML, PyCharm, anything that can edit code. And you can essentially use it to build your own functions locally, test them locally, and then launch them on a distributed cluster with all the tracking, the auto scaling, all the aspects of operations that are essentially built automatically for you. And there are a lot of tutorials that you can run locally or in a cluster. Next. The paradigm shift that MLRun brings is essentially before you had to write some code by a data scientist or someone else, and then you bring it to machine learning engineers that will convert it into containers and elastic services and add instrumentation and security and logging and tons of other operational aspects, artifact management and registering models and experiment tracking and so on. Once you've done that, you build workflows from those individual functions that have the data processing, the training, the testing, the deployment, and so on. And finally, you need to build the monitoring. Each one of those tasks is usually done in a silo and with a lot of manual activities. What we're doing in MLRun is essentially automating the entire flow. So someone can write his own code in his favorite development environment. He can essentially, with a single click or a single API call, automatically convert his code into a fully elastic, auto-scaling, production-grade service that automatically tracks all the information, artifacts, data, and so on. He can take those functions and build real-time or batch pipelines using those individual functions, again, automatically with a single line of code. And the monitoring essentially is built in because all those aspects of all those classes that we're using internally, they know how to monitor the activities, whether it's a data analysis or model monitoring for analyzing accuracy and drift and so on, or infrastructure monitoring and so on. And all of that data is fed again into the system, so we can use it to trigger things like pre-deployment or retraining or tune our model or do explainability on the data that we've used. So this is the general idea, and we're going to show how it works and especially how it applies into Hugging Face. Great. So before we dive into the demo, which essentially has two parts, one is the serving, the other one is essentially the retraining automated flow. So let's look initially, what is MLRun? We mentioned MLRun, just go to mlrun.org. You have lots of links and documentation. The best way to start with MLRun is just going to the MLRun documentation site. You can go from mlrun.org directly into it. And the landing page, there's a lot of new content, by the way, from the last few weeks, but you can see it's organized by what you want to do. Like usually you want to ingest data or build a model or use the model and deploy it into real world applications, and finally monitoring. For each one of those sections, you have documentation, tutorials, and videos to show you how to do it. For each category, you may have different things, like you may deploy in batch or deploy in real time, so you'll have different examples and tutorials. There's also a lot of different components built into MLRun that serve this sort of flow, like those serverless functions that are automatically taking your code and building Elastic service into it, all the aspects of data processing, workflows, distributed runtimes, and so on, real-time pipelines that we're going to use in a minute. And there are links to each one of them and full documentation. If you want to understand how it works, you just go into the tutorial section. You have many different tutorials. Some of them include videos for each step of the flow, from doing training, doing deployments, pre-baked deployment, pre-baked models, serving, building your custom model serving, advanced serving, building, model monitoring, batch inference, drift analysis. All of those have different tutorials. And specifically, one of the things that we're going to show in this demo is this concept of real-time serving pipelines. Why do we call it serving pipelines and not serving endpoints? Because endpoint is merely serving, the model itself. Usually, when you build an application, there's aspects of intercepting a message, which may be in JSON, and transferring that messaging to another structure, maybe bringing some extra data and enriching the data, doing the scoring, sometimes even building an ensemble, and then doing set of post-processing steps like processing the data, writing to a database, and so on. So you need a multi-stage flow that encompasses all of those different steps and could be treated as one entity when you're doing rolling upgrades or when you're debugging it, and so on. So this is this concept of real-time serving pipelines, or graph, as we call them, that you can essentially build topologies, and we'll see how we can build an NLP topologies with some pre-processing and Hugging Face model and post-processing. So that's without further ado, let's move into the demo. What we're going to show is two different flows. First flow is the more trivial one. I'm going to take a model from Hugging Face. I'm going to build a serving pipeline using that model, and I'm going to try that with the gradio. The second scenario, which is more advanced, is once I have a model and maybe I have a new data set that has up-to-date information, maybe I want to do retraining, or maybe I want to recalibrate my model with more accurate or correct data, then I want to build a training flow that essentially knows how to grab the new data, do some data processing, train, do evaluation, testing, maybe optimize the model using something like Onyx, and then redeploy the model into the existing endpoint, so I can essentially just go and swap my, just work with the rolling upgrade against the new endpoint. So with that, let's look at the first notebook, which is the serving application notebook. So what we need to do in MLRun, usually everything is a project. Project usually also maps to like a Git repo, so we can save our work and collaborate with different people. So we just import MLRun, we create a project. In this project, have a serving function. And this serving function essentially have a few steps. We're going to see that in a second. And the way that this serving function works, it has multiple steps. You can see there is a graph. This graph has three steps. It's a very simple graph. You can build graphs with sort of branching and joining and so on, but this is more of a simple flow of, I'm going to intercept a message through HTTP or streaming technology like Kafka and so on. I'm going to do some pre-processing. I'm going to do sentiment analysis using the Hugging Face model, and then post-processing. Hugging Face is built into the new MLRun releases, both for serving and training, so you don't even need to build anything special. In order to build this graph, I need to just have a pre-processing function. I need to add another step, which is the Hugging Face model serving class with a bunch of parameters with your model, with your tokenizer, and so on. So again, you don't need to build anything from code. You just need to specify the models you want to use in the model serving, and then some post-processing. This is essentially a code that I have in this serving function. I don't need the class for serving the Hugging Face because it's a built-in class, as you've seen. I only need those two pre-processing and post-processing function. Very naive functions. Essentially, the model serving is compatible with other model serving frameworks like TensorRT and KF serving. So the usual drill is that you need to pass like a dictionary of inputs vector for the scoring, and then it returns sort of a dictionary with output vectors for the responses along with other data. So we need to transform the text that we received. Again, we could do many other things in those steps, but this is just to show you that we're transforming the text that arrived into a serving request. And then we're taking the post-processing is taking the serving response and converting it to some text message. Okay, so very simplistic. So we build this application pipeline with multiple steps. We save it in the project. So later on, when we load or save from Git, we can reconstruct the state without doing any extra work. The next thing we want to do is take that pipeline and simulate, see that it actually works. So the way to do that in MLrun, you're just saying, take this function, build a simulator around this serving function. So an in-memory thing that simulates this entire application pipeline that we described. And then I can just push requests into that pipeline and verify that it's doing the work it's supposed to. So we're just sending a request for prediction. We give it some text, and then we can see that there is a sentiment. You see, sort of the return value is sparse because we did some post-processing. So we see the response, and that's it. At a certain point, after we debug, we go change the code, debug, etc. This is a nice thing you can develop locally. Certain point, we want to turn it into a real-world endpoint that runs on Kubernetes and has API services, and we can do even rolling upgrades and so on. The only thing we need to do is take this function that we defined here and simulate it and say deploy. When we do this deploy, in the background, it's doing a bunch of things. It's building containers, it's pushing them into repositories, it's building the Kubernetes assets, it's building API gateways, adding security logging, all of those things that take a lot of manual time is essentially built automatically. And eventually there's going to be an endpoint, which is serving this entire pipeline, not the model, again, serving this entire application pipeline. Now, in order to test it, we want to do something slightly more interesting. We want to use gradio and service as a way to test this endpoint. So we're using a very simple code here to build. If you're not familiar, gradio is also sort of part of the Hugging Face family. Maybe Julien can shed a few words on that later, but it's essentially a nice way to build front ends for those things with minimalistic Python code. So this is essentially I'm building some widget here. You see it has few cells that accept some text, and then calling my model in this URL that was generated by this endpoint. So again, I have a model serving pipeline that is behind this endpoint that we mentioned. I'm using that URL and using it in the gradio, essentially telling gradio where to submit the inference requests to. And then just by launching this, when I launch this, it will essentially build a local yeah. So it's building a local widget into my notebook, but it's also building this app, which is let me see if I'm going to click on that, you'll see that it's actually a real thing here. Let's say I hate flying, and it's sort of a negative thing, etc. So I built a complete application pipeline that that did everything, including the pre-processing, the Hugging Face model scoring without knowing anything about Hugging Face, and some post-processing. I tested locally, and I deployed it into an elastic auto-scaling service with all those additional features. Now, once I build the model, that's nice, but I may want to take some fresh data and build a fresh model and deploy it and sort of substitute my existing model. So for that, we're going to build a training pipeline that will automatically deploy the new model into production. So what we're going to do here, again, just import MLrun, we log into the project, and we're adding another function into our project for training. This function essentially has the training, the evaluation, the testing, the optimization, and so on methods in it. And then we're building a workflow that has all those different steps. So if I'm going into that training function, we can see has some code for preparing the data set, essentially taking some airline data set that is recommended by Hugging Face to tune our NLP sentiment analysis model. So it has to like drop some columns and do some modifications on the data set. Then we're running a method for training, which is using the Hugging Face training way. Then we can do optimization, which is converting the model into sort of a Onyx, higher compressed and higher performance model. Okay, so those are the 3 steps that we need to build. And the way that we take those into a workflow, we essentially have a workflow file. The workflow file is written in sort of the semantics of Kubeflow, but it doesn't necessarily have to use Kubeflow for the runtime. You can even debug it locally and essentially simulate. MLrun knows how to simulate Kubeflow locally. So my pipeline has several steps. The first step is to get some parameters, like the data set, the pre-trained model, etc. And the first thing it will do is prepare the data set. The second thing it will do training. It will train this data set with the outputs of my data preparation and potentially some parameters. The next one will be to optimize the model. And finally, we're going to deploy the serving function. So we have 4 steps in our pipeline that will essentially take everything we did, take the data preparation, build the training, can do testing and evaluation, can do optimizations, many other tasks, and finally, not just building the model, it's actually deploying it. Do we really deploy to production? Probably in reality, no. We'll deploy it into a staging cluster or development cluster, but it can also build in 2 separate flows, one to build it into development environment, and the second to build it into a production environment. By the way, those workflows can be triggered automatically using your CI systems. If you go to MLrun documentation, you'll see how it works within GitHub Actions or Jenkins or any other CI framework. So you can build those flows and just run them. So once we execute those workflows and we open the MLrun UI, sorry, what was it? Then we can see the execution of this. I'm not going to run it because the training takes about 15 minutes. So, but you can see that essentially in MLrun, we have the pipeline with the data preparation, training, optimization, and deployment. For each step, I can see the artifacts that were generated by that, the results of every step, the logs of the pods, the Kubernetes processes, and so on. The nice thing, for example, when we're training the model, MLrun supports Hugging Face, so it will automatically generate artifacts for the different metrics of your training. It will save those artifacts. So if you want to do comparisons and sort of experiment tracking, it's automated. You can essentially see all those different data that is being generated by every execution, all those results. You see the accuracy and all that. Everything gets logged automatically into MLrun. That's part of a concept in MLrun called auto MLOps. That you don't need to do the MLOps. There is essentially, you just import some classes that will do the MLOps work for you. So you can see the training is doing that, and then optimization and deployment. If we're going into that project dashboard, we'll see that we essentially have the serving. We actually have 2 serving classes here. We have the different jobs that are already finished. We have the models being registered and so on. want to go into the to their actual real-time serving functions, we can see their performance, their activities, etc. We can see that there is an actual serving function that was generated with all the code, and the serving function is essentially a serverless function that implements this pipeline. MLOps serving also provides distributed mechanism. You can actually build your serving pipeline from multiple containers, like maybe one with GPU, one without GPU, but you can read more details on that in the documentation. So the nice thing, after we reran this training loop, then we could essentially go and read and test and essentially load the serving function and do another prediction. This time the prediction has a different score because we trained it with the airline data. Now the new model that we've built is a lot more accurate and encompasses the new data set. So that's in general. We also have here a piece of code for generating the G radio for it, but we've seen that already. But what we've learned here is that we can essentially not just build the serving pipeline, which is a lot of headache, and you've seen how we've done it very quickly and easily, but we can also build a fully automated flow for retraining the models or building models based on more accurate data and automatically deploy those into production. So all the operational aspects, even a data scientist can learn that and use it and essentially build operational products without having lots of DevOps and MLOps skills. And you've seen what I've done here in the notebook is not too complicated. We're going, by the way, those notebooks, we'll create a Git repo and we'll send over so everyone can look into those notebooks. Okay, anything to add, maybe Julien or Noah?
Yeah, I think one thing I want to highlight is this is really how you want to do things because from a training perspective, you really want to start with an off-the-shelf model to minimize, time and effort. And like I said, we have 80K plus models, so it's likely you're going to find something that's close enough to your business problem. So start from there, evaluate on your own data, with whatever metric makes sense for that business problem. And if it's good enough, then you're done. Don't be frustrated if you're not training at all. Be happy because you save yourself a ton of trouble. And you can move to production faster and then move on to the next project. If you need to get a little more accuracy, then what Yaron showed is the proper way to do it. Find a data set that is close to your business problem. Again, you may find it on the Hugging Face Hub or elsewhere on the internet. And that saves you from collecting data, cleaning data, labeling data, which is always, at least to me, not a very fun thing. And train, and then you just iterate like that. And here, of course, it's a short demo, so we only show one run, but you would do this again and again and keep tweaking and keep adding data or trying out different models until you get to the accuracy that's good enough for you. And so yeah, this is really the way we encourage you to do machine learning, the iterative way, reusing stuff that's off the shelf, focusing on getting your model in production quick and testing it in production with real life data, because that's the only time when you'll know if it's doing a good job or not, right? The sandbox always works. So it doesn't teach you anything. You get to production, then you start learning.
I think another scenario, another use case for training would be that you get fresh data, whether, for example, your images that got captured and they got labeled, and you want to essentially update the model to incorporate up-to-date information, or even text that you sort of had chatbots, etc. And you're learning from behavior, you're labeling, you're fixing stuff, and allows you to essentially zoom in and have better and better accuracy over time. Sometimes even there is sort of drift even in deep learning models. Maybe some sentiments that were true for COVID are not true for regular world, or maybe the entities or other aspects are changing with the fashion. So you also need to train models even when it's deep learning and unstructured data.
Yeah, I really was impressed with your new stuff here, Yaron. I think that
Thanks to Jonathan, our data scientist here, that did this demo. Actually, you built this entire demo in a day, I think.
wow.
So.
Well, what I think is very interesting about what's happening is that Hugging Face is becoming, we look at the data, right? I mean, it's the most popular open source project right now, and that what could be a new way of working is that people are going to be pushing lots of models into Hugging Face. And so there's essentially like a new target, which is the Hugging Face model repository, because many people that are looking for work or they want to demo the capabilities of their company, they're not just going to be pushing their model into a production environment, which is obviously helpful to push into production, but the production environment may in fact be Hugging Face. And so what's really interesting about ML Run is that people that are maybe lacking some of the deep skills that it would take to maintain a very complex retraining pipeline can actually use ML Run and put more models into Hugging Face and constantly improve the models, and then people will take someone else's model that was retuned and then retune it themselves. So I think it's a very interesting new world we're headed into. And I'm curious, the combination of ML Run plus Hugging Face, if that could take something that's already exponential and even add a little more exponential boost to it.
Yeah, I think another key point on the application pipelines is that we already have several big users, financial institutes, and other using, NLP and Hugging Face with ML Run serving pipelines. The big pain that they had was that usually again, NLP is not just like serving the model. They have to do, for example, there's a PDF document that lands on an S3 bucket, and you need to read that PDF and transform it from PDF to some text and parse some sections in it, and maybe it's forked to like analyzing the images in the PDF and then text. And there's a full application pipeline in reality, which is beyond just scoring them all. And the way that they handle it until now is essentially there's a software team or data engineering team build some steps, and there's the data science team building an endpoint, and then some third guy is trying to build an integration across all of that. And guess what? What happens when you're doing a rolling upgrade for the entire application? That's a nightmare. What we've seen here is that you can build an application pipeline where the model, or even multiple models, maybe I have a model for images and a model for text and another model for classification and even chaining one after the other to get a result or creating ensembles. So we can build a full application pipeline within a matter of hours or days. And once we debug it, we push a button and it's ready for production. Think about building those technologies, you need to combine streaming and Kafka and Flink and all those things. This is huge effort for developers that understand how to build containers and endpoints and so on. This is huge engineering effort that you can summarize in building a DAG of activities and say launch and get it done.
This is a fascinating conversation, and it looks like our audience wants to get involved as well. We have some great questions in the Q&A panel, so I think this could be a great time to take some questions. The first one I think is for you, Julien. Isn't transformers also deep learning? This was actually asked by a couple participants.
Oh yeah, it's totally deep learning, and the transformer architecture is totally based on deep learning. And the point here is really that the number one way customers are doing deep learning today, if they want to get state-of-the-art results, is to work with transformer models. So whether you do natural language processing or speech or computer vision or other things, the top models today are all transformer models. So it remains to be seen if transformers will also get into the more traditional machine learning workloads like tabular data and so on. But it looks like there are some ongoing efforts there. So mostly deep learning today, but I'm also thinking, tabular data and enterprise data is next on the menu for transformers.
Yes, I can take the second question, Star, on the.
Yep, let me just read it out for everyone. Can MLRun support building model in dev account, AWS, and promoting the models to upstream environments and other accounts? Go for it, Yaron.
Yeah, so in general, the way that MLRun works, so you can see that in the diagram, there's a concept of a project. The project has all sorts of things in it, and it's backed by sort of an archive or a Git or something like that. And the way you work is just like I've shown you essentially a quick path here without going for production and so on. But you build your code, you debug, you keep building, and at some point you're saving it in like a source repository, like a Git, and tagging it with the label. And then someone else can just go and load it into another cluster. Could be in the same place, could be on the edge, could be anywhere you want. And then essentially when you load the project, it essentially loads the code, the metadata, the configuration, everything essentially is loaded and can run into production. Now, because you have different versions, then you can have a development version, a staging version, a production version. It's essentially leveraging Git for that versioning aspect. And you could, because we have also the integration with the CI systems, it's all can be automated. So you can push code into your development and it will automatically trigger sort of development tests and so on, or you can push code to master and it will automatically trigger a deployment flow with canaries and so on. So again, this works well with multiple environments.
Excellent. And there's another question here, I think possibly for you, Julien. What's the estimated cost in dollars of deploying transfer models on your platform? Very few people deploy transfer models due to the cost. What can you say about that?
Oh, I would disagree with the fact that very few people deploy transformer models. Quite the contrary. We see a growing number of customers doing that. Whether they use our own inference services or some of the inference services we have partnerships with on the cloud. So the deployment is is happening. Still, those models are big models for sure. So I think first of all, you want to start small. You want to start. It's very tempting to always go with the huge models, just like it's very tempting to go with the huge cloud instances when a small one would actually do the job. Same story. So start small, benchmark, and then scale up if needed. Then of course, and Yaron mentioned it, model optimization is extremely important. And in fact, we have an open source library called Optimum. You'll find it in our GitHub organization. And Optimum lets you optimize your transformer models for training and inference, but here we're talking about inference. And so you can use ONNX, you can use the Intel neural compressor, and just as of last week, I think we added Intel OpenVINO as well. So you can, in 2 lines of code, literally, you can do quantization and all that good stuff, and shrink your model, 3x, 4x, 5x. So I think there are lots of new developments out there that make it much more cost efficient to deploy those models. But then again, at the end of the day, it's accuracy, and model performance needs to be balanced against the business problem. You don't need 99% for a ton of problems, right? So if a smaller transformer gives you, let's say 90% accuracy, and that's good enough for your business problem, then that's it. Why go and deploy the biggest, largest model that brings incremental accuracy, but with diminishing business returns? So as always, it's a balance between cost and performance and what the business problem needs. But yeah, go and check out Optimum, and I'm sure you'll find you can shrink your models massively and deploy them on smaller GPUs and potentially even CPU, right? Like a
Oh,
lot
yeah.
of NLP workloads work perfectly well on CPU. And again, the Intel Neural Compressor and OpenVINO are great ways to do that. And you'll find, you can run cost-effective transformers.
Well, I was going to say, Julie and I both took the AWS machine learning certification exam, and I won't say what's on the test, but I will say you should know about how to save costs for doing predictions. And obviously a batch CPU-based prediction with a small model could work for many scenarios.
That's excellent.
So there were
There's
a couple of questions here on like third-party
yeah,
tools.
just one for Noah Gift before we go. It's actually in the chat, so it's difficult to see, but are you using makefiles with MLRun and Iguazio? Interested to hear if makefile is a part of the CI/CD process or if it's bypassed by Iguazio.
So I think makefile is always complementary to any workflow. So you can always use a makefile in any environment. I personally lean towards, I wonder in the future if, let's say again, 2023 and beyond, that the Jupyter Notebook, which I'm a huge fan of, and I've from the very beginning, when it even came out, before it was even a notebook, I've used Jupyter Notebook and IPython. But I do wonder if we're about to get rid of a little bit of it. And the reason why is that it seems obvious now that we're headed towards more of a developer type workflow versus this only Jupyter-based workflow. And so that's when you start to see things like a makefile come into play, is that the point of a makefile is more of a convention that allows you to do the same thing locally that you would then do in your build system. So if I have a makefile that says make install, make lint, make test, make deploy, then when I go to the build system, I just put in that same command and I do a deployment. So it in my opinion, a makefile is never like mandatory, but it often is a great convention if you're in a developer workflow. And so I would say, why not? Why wouldn't you use a makefile? And especially in the new world we're headed towards, my prediction is that I think there'll be less notebooks and more of a developer-centric workflow.
Yeah, we actually have it in one of our chapters in the new book. So like how to balance the use of code versus notebooks and when to use what. So stay tuned. So,
Excellent. And there's a bunch of questions now for you, Yaron, around MLRun and whether it's environment agnostic, whether it can be used with SageMaker. Should, in theory, someone be able to run this code as easily within SageMaker as they can from their local computer? So can you say something around all of these questions?
So that's why I also shared the slide here, so you can see my slide here. So you can see essentially how MLRun works. There is sort of a server side and a client side. The client side can run on everything, and it was also tested with SageMaker and Azure ML and any sort of Python and notebook system. Essentially, just like do pip install, and you configure a couple of environment variables, and you're done. The server side is running. Again, could run on your local Kubernetes, on Minikube. There's also a mini version with just containers with Docker Compose, but that's mostly for playground and testing. But it can run on Minikube, could run on GKE, on AKS, and EKS, all the cloud Kubernetes environment. There's also part of the open source deployment. There's like a cloud formation that builds everything for you in Amazon, so you don't even need to install Kubernetes and all of that. What you see here is that essentially what MLRun does is turns your requirements into serverless function that, and also use auxiliary services like Kubeflow and other services. Another thing that it's not shown here in the list, that it also has third-party services like Azure ML or SageMaker Autopilot, etc. It can launch the training, for example, on an AutoML external service. It's not really shown here, but that's so we can essentially use SageMaker, either just use SageMaker Designer and essentially launch against workloads that will run on AKS on Amazon, or you can actually use MLRun to build a workflow around the SageMaker services like Autopilot and others. Same for Azure ML and Google. There's actually a nice demo. One of the demos is around showing how to use Azure ML with MLRun including AutoML and a few other tools. So that's on that front.
Excellent. And we're nearly out of time, so we'll just take one last question, and we really invite you to join the community, ask additional questions on the Slack channel, and we'll be happy to answer them all. This one is also for you, Johan, about the difference between MLRun and MLflow, Bento ML, some of the other open source frameworks out there. Can you say a few words on that?
Yes, I see different frameworks, so they're not, there's no real full overlap. If you think about what MLflow is mainly about, is around experiment tracking. It's more around the development workflow. MLRun also has experiment tracking, but it's sort of auto experiment tracking, and it's built for production. This is not what MLRun is about. MLRun is about taking a piece of code and automatically building all the assets from it, and it's divided to feature engineering. So it has a feature store for it. The development workflow, so it's more batch and workflow-oriented workloads. You have the real-time, which is more like real-time functions based on the Nucleon engine, and you have the monitoring. MLflow doesn't do those things. MLflow does experiment tracking, maybe helps you organize projects, maybe helps you deploy serving as an endpoint on a third-party serving system. It's not what MLRun does. I see also another question here around Seldon. Seldon has serving, but Seldon is not a serverless technology. Essentially, you need to build containers and YAMLs and all of those, and Seldon is sort of a framework for launching those. MLRun is serverless. That's one difference. You essentially give it a piece of code. It builds the entire service, including auto-scaling and APIs and everything from it. And the other major difference is that MLRun provides pipelines. Seldon provides essentially very basic serving, very confined to the serving. You can't build a full application with Seldon. You mainly focus on the serving part. This is really the value that MLRun serving brings, is ability to build application. Another thing that because MLRun has the metadata services to save an object like a model or a data set or a feature, etc. When you're doing training, the training automatically builds a model object. The model object is not just the pickle file or JSON file that was generated. It includes information about the schema of the data, about the statistics for the drift analysis, about the parameters, the accuracy, and all of that. So it essentially has glueless integration with the serving layer and the monitoring layers without writing a single line of code. And what you've seen here is that I built training and I said, deploy the output. And then I'll open the monitoring screen. I'll see the drift analysis. I don't write any code because we have a combined schema, a common schema across all those different steps. And this is really the innovation, building something more holistic with a common metadata layer versus going to 4 different services, each one its own authentication, its own logging, its own consoles, and adding lots of glue in order to create a real solution among them.
Excellent. Thank you, Aaron. So we're really running out of time. I just want to quickly share a couple of ways for people who might want to try MLRun. There are 4 different ways. We'll share the link with all of you right now. You can try it as a small scale deployment on your laptop, large scale deployment on-prem or on cloud, on Kubernetes, on cloud formations, or as a managed solution as a service. So we'll just share the links in the chat. And we'll quickly launch the last poll. I know everyone's excited to see the results. So we want to hear from you. How do you deploy your models today? And now we'll show you the results. We'll start with the first poll of the challenges when deploying a Hugging Face model. I know we're all excited to see that. So 25% of you said that model monitoring is the top challenge. 20% said infrastructure costs, 20% said CI/CD automation, and then data pipeline after that. 9% of you have no challenges. You're very lucky. And finally, canary deployment is the last option. And regarding the poll we just ran right now, how do you deploy your models today? So almost 40% of you are using open source frameworks, which is not surprising at all. It's the way to go. And 27% of you are actually looking for a good solution right now. 24% use off-the-shelf enterprise solutions, and 9% don't need to deploy models at this time. So we're really near the end of our session. I know we went a couple minutes over time, so thank you all for staying with us. We just wanted to say that we have a host of additional MLOps resources available for you on our website. Go to iguazio.com/MLOps. You can see previous episodes of the MLOps Live webinar series featuring Microsoft, GitHub, S&P Global, Ecolab, NetApp, and other thought leaders in this field, practitioners that are running real pipelines in production. You can also see some of the blogs and videos that are available to you, white papers, case studies, it's all there. And finally, I'd like to thank our incredible speakers for a really great session, very, very interesting. And thank you for answering all of the questions. We invite you again to join our Slack community. If there are questions that we didn't get to, please ask us there and we'll be happy to respond. So thank you all for being here with us today.